Hello, Carlos. Thank you for your introduction again. Today is gonna be probably a little bit longer than usual. I promise I won't take much time. So quickly, let's just go to it. Let me see if I can share now. Okay, can you see it, Carlos?
Yes, perfectly.
Okay, great. So we are going to be talking today about Salmonella control, and something very important, as my colleague Carlos just said, is that this can be quite a challenging matter, right, in our farms, and we have to be especially careful and have our eyes well opened because as we will see, there are so many things that can be involved with it, right? So as I said, I'm going to be talking about Salmonella, but we are going to talk about it from a special point of view as a company, right? We mainly will be talking about controlling it from our point of view as BBZIX, and we will see the importance of the water disinfection, the water treatment, and the general disinfection processes in our farms. All of these is the fundamental tools to control Salmonella. I can imagine that many of you have already been attending to our previous webinars. So many of the things that we are going to be talking about today, probably they will not be new for you, right? And you will see why, because BIOFILM is going to be important again today. Because it can get involved with anything related to Salmonella. So let's start. There we go. So Salmonella is normally a difficult and tricky one to control for one reason, right? And this is because there are multiple aspects involved in it. So because of this, we cannot help in the whole process. We cannot help you in the whole process, but there are 3 key points where we can help quite a lot, and we will be dealing with these 3 points during this talk. First, we will talk about the drinking water, as it can be. There we go. As it can work as a vector, and also the biofilm related to the water, which is pretty common inside the pipes for drinking. This biofilm can be a reservoir for Salmonella. We will also be talking about cleaning and disinfection, another point where we can help a lot, because as we will see later on, failures in this process and biofilm again related issues will make us replicate Salmonella within different batches. And also how Salmonella is going to affect to the intestinal balance and how we can help you by achieving a good intestinal health to control the Salmonella. And finally, we will quickly explain a couple of trials and real cases that we have done. So what happens with Salmonella? Salmonella belongs to the Enterobacteria group, and it is an ubiquitous bacteria with a very high adaptive capacity and persistence on the environment, right? Just bear in mind that it can persist for months on the environment and even for years if it has got access to an organic substrate. In a natural way, it will be found within the digestive tract from mammals, reptiles, birds, and even insects. So you can imagine that it can affect pretty much any kind of animals and humans. And we can find it anywhere. For this reason, something like pest control is another key point, for example, to control it. But also you can imagine, as we already said, that there are many factors related to Salmonella. And because of this, it is not a problem that we can just treat with one only thing or just a single protocol. Otherwise, we need to have a complete set of measures in place to control this problem. One of the main things to do is to control the entrance of Salmonella, right? So we have to know which ways Salmonella can get inside our farm. So it can be transmitted to the progeny. So imagine how important it is to control Salmonella on the reproductive animals. Also, wildlife, as we already said, very important to have everything around the farm in a good state, well tidy, and having these safety perimeters, right, to avoid wild animals to get into the farm. The external staff and visits as well into our farm can be a source of Salmonella. Even it can be spread within the same farm in different buildings. Of course, animal feed is very important, and we have to make sure that we get this feed free from Salmonella, free of Salmonella. But we also have to pay special attention to where are we storing it and how we are distributing it, as we can contaminate the feed. We can have a free of Salmonella feed, but we can have some biofilm in the containers, and that can contaminate the whole thing. So, for example, inside of the screw conveyors that takes the feed from the silos to the feeders. But overall, where we can help you the most is with the water as a way of entering, also in the reinfection due to failures on the cleaning and disinfection, and also with the digestive health, right? Not that much to avoid Salmonella from getting in that case of digestive health, but to minimize the damage that it can produce once it is already inside, right? So these are the three topics that we are going to be focused on today. As I said, water, the cleaning and disinfection process, and the intestinal health. In regards to the drinking water, we know that Salmonella doesn't find itself especially comfortable in the water, right? It is facultatively anaerobic bacteria. So in general terms, due to the oxygen present in the water, it is not going to be the best environment for Salmonella. So it will not replicate there, but it can use the water as a vector if we have a contaminated source of water, or there is a previous fecal contamination. In that case, we can, well, we could have a great safety perimeter to avoid pests getting inside the farm. But if the source of water is contaminated even by these same pests somewhere outside the perimeter, we will get that contamination through the water. And of course, and as I already mentioned, the biofilm inside the pipe is going to be especially important in regards to Salmonella, as it will be a reservoir for the bacteria. As you already know, biofilm will modify the surrounding conditions where Salmonella doesn't find itself especially comfortable initially, and with this change, it will be a perfect place for it to be and to grow. So drinking water can be affected in two different ways, being a vector or being a continuous reservoir because of the biofilm. We will also talk with more detail about the cleaning and disinfection process. Right in here, we have to know that this step might be responsible for a reinfection of consecutive batches, right? I mean, if the whole process is not perfectly carried out and there is a fail, then obviously we can replicate Salmonella from one batch into the next one. In here, we are also going to be well affected by biofilm again. Biofilm is associated to many of the failures that we will find, that we will have in regards to the disinfection processes, right? And that is why we need to pay special attention to biofilm here as well. Not only inside the pipes, but also in any kind of surface. We normally think about biofilm inside the pipes, but remember that it can happen in any kind of surface. Also, the transmission from the outside of the farm, but also the one inside the farm. We also need to remember about the silos, are we disinfecting them? And the same with the distribution systems from the silos to the feeders. You have to bear in mind that there will be plenty of nutrients there, and therefore biofilm, which can happen just with environmental humidity there. So it's very likely that we could have Salmonella related issue in these parts of the equipment as well. Just a few pictures that we have shown you so many times. during the other webinars, but just to raise awareness of how important it is to be careful with biofilm, not only inside the pipes, but again, in any other kind of surface. It will be responsible for failures in the cleaning and disinfection program. So in order to understand this, we have to quickly review the basics about biofilm. We did a deeper webinar just on that, but we will have an overview now to just remember how it will affect us in regards to Salmonella, which is our topic today. As you know, we can define the biofilm as a microbiological ecosystem which is adhered to a surface forming a layer or a film, and which is characterized for being able to secrete a mucopolysaccharides layer that cover the film and protects it. What does this mean? So the surrounding to those bacteria that will be generated this mucus substance that will be basically protecting the biofilm. So the surrounding conditions have already changed, and there will be a microbiological population formed by different species. This is very important to understand, just to know that we can have different bacteria there. So in some cases, we can have just a monofilm, where it's just one kind of microorganisms causing the film, but the common cases is that we will find them with plenty of species, even involving different fungi, viruses, yeast within the same biofilm, right? We have to understand biofilm as a whole ecosystem where the microbiological population interacts inwardly, but also with the surrounding environment. So basically, it does generate, as we can see on the pictures, there is a first cell arriving and sticking to the surface. Later on, more will come and adhere as well, and then multiply themselves and grow for later on secrete this mucopolysaccharides layer. And then we will have the mature biofilm, and here is where Salmonella starts to be part of this biofilm. Maybe the most important thing to know at this point is that biofilm will generate from 20 minutes to 4 hours. So we know it can happen extremely quick, and it can happen soon after starting a new batch, even in day-old chicks, right? Just remember that we can find biofilm really fast after starting a new farm that it was previously clean. When we have an early biofilm, it will start developing and maturating, and it will be modifying the surrounding conditions, as we said, providing with a suitable environment for many other different bacteria, right? That initially were not that likely to get in there. We talk about Listeria, which has been proved to have a greater capacity to be in biofilms if there is Pseudomonas previously in that biofilm, right? This happens because Pseudomonas is a bacteria with a great capacity to create new biofilms, as we will see later on. And the conditions that generates in these environments are very suitable for subsequent Listeria colonization. The same is going to happen with Salmonella then, which is not very likely to create biofilms by itself, but finds a very good environment within a mature biofilm. What are we going to find inside the biofilm? The external part, where there will be an aerobic metabolism, and then the internal part, where there is going to be an anaerobic metabolism, right? Remember then that bacteria such as Salmonella are going to find a better place in the internal part, in the deeper part of the biofilm, where the conditions are much more suitable for it. But not only Salmonella, there are other different anaerobic bacteria associated to mature biofilms, as it can be the case of Clostridium. So what happens? These pathogenic microorganisms are going to be very well protected in the deepest part of the biofilm from the action of any kind of treatments that we could be using for cleaning and disinfection, or just for water treatment, right? Where are we going to find it as well? So we said before that it can happen in any kind of surface, even the pipes, any walls, roofs, drinkers, ceilings, the clean surfaces. Just remember that it can be generated everywhere. The most important thing to avoid biofilm, as we explained in more detail in that other webinar, is to reduce the predisposing factors. All those substances providing nutrition, roughness, temperature, slower water flows inside the pipes, etc. But we are not just going to see them all in detail today because it's about Salmonella. There are different bacteria which are more likely to generate biofilm, as we said before, Pseudomonas. So they will firstly colonize the surface, and then they will make it easier for Salmonella to colonize as well by changing these conditions, which is what happens when the biofilm gets maturated. What happens in this situation with when we are trying to treat with chlorine? So the mucopolysaccharide layer is going to be protecting the biofilm, right? It has got a very low permeability, and also it is very difficult to detach. So when we are treating the water with chlorine or any chlorine-based products, we can see that there is not much that they can do against the biofilm, right? And therefore the reservoir will remain there because it will be well protected against the action of this kind of disinfectants. In this study by Ma and O'Toole, it was seen that the bacteria creating colonies within biofilms are from 10 to 100 times more resistant against the action of biocides, right? This is extremely important, not only just for water treatments, but for any kind of disinfection process, right? I mean, if we think that with a certain amount of disinfectant, we are going to finish with a bacteria, then just bear in mind that if this bacteria is found inside of a biofilm, maybe that is not going to be the reality, and we will need a higher concentration of disinfectant. This is one of the main causes for unsuccessful disinfection processes. Here in Spain, at the Poultry Congress that took place in Valencia in 2008, it was proved that there is a high correlation between the capacity to generate biofilm from the bacteria, or just the presence of biofilm, and the positives for Salmonella. So the greater the proportion of biofilm was, the greater the proportion of positives for Salmonella was as well in water deposits and drinkers. There is another interesting article from 2019 where they did an in-farm study, and they literally explained that all the mechanisms used by Salmonella to persist are not known. Its capacity to generate biofilm is key for Salmonella to survive within different batches, right? So it can be transmitted even after emptying the farm to the next production batch. And also mentioning the iron. This is important. It will be important in some parts of the world. It might not be important in some others because it will depend on the quantity of iron that their source of water has got, right? Iron will make sulfite-reducing bacteria proliferate, and this kind of bacteria they get on well with Salmonella and Clostridium, both of them, so they will facilitate as well its proliferation. As I said before, this is important in places where the source of water contains iron in a natural way, and remember that we have treatments to just amend it, but also bear in mind that it might be due to all water systems iron made, right? Don't forget about it. It's not that common right now, but some places still have this kind of pipes. So likely to find Salmonella in these two cases. We have as well different methods to see if we have biofilm. The most indicated way is to perform a water analysis in both, start and at the end of the water lines in order to know if there is a greater concentration of microorganisms. But just remember that we can also do surface sampling, also visual inspection can be helpful. And then obviously we have to know the predisposing factors so we can reduce them, and we have to know which treatments we can perform, right? Right, so here are the treatments. We said that chlorine was not going to help much when there was a biofilm problem. It could help to reduce the amount of salmonella in the water when the water just works as a vector, but it will not do much against biofilm, right? We also know that chlorine is extremely volatile, so just be sure that it won't reach the whole length of your water system. Then we have different biocidal treatments, and we have to pay special attention to the oxidation potential to remove biofilm, right? We can see that hydroxyl radicals are the best ones. Free chlorine and hypochlorite have a reduced potential, and hydrogen peroxide, which is the one we always advise, has got a potential of 1.78. But remember that hydrogen peroxide is a precursor of hydroxyl radicals, and therefore we will have a very good combined oxidation potential there. Which treatment do we propose, right? So we are working in two different ways, with a corrective treatment and a preventive treatment for Salmonella. The corrective treatment is the one for cases where we already have the biofilm there, so we will for sure we will have the Salmonella, and we need to remove it, right? The preventive treatment, which is the ideal one, is the one that will prevent us from having this biofilm at any point. Remember, we saw before how fast it could be generated. The corrective treatment can be done both in the presence of animals or without the animals. In the presence of animals, we will be removing biofilm and the animals will be there. For these cases, I will always advise using BBZIX Plus. Remember that it is based on 50% hydrogen peroxide with silver, different prebiotics, and the enterocix nucleus. So we will give a higher dose during the first 1 to 3 days, and this will provoke the descaling and dragging of biofilm inside the pipes. So we only advise this when you cannot do a complete emptying of your premises and at the end of the production batch. So in those cases where we cannot wait and we have to solve the problem straight away, right? So bear in mind a few considerations here. You will have to do flushings and eliminate that water as much as you can, and ideally early in the morning before sunrise, right? So the animals are not drinking that much yet, and this will help you to take all that biofilm out of the pipes. And after those initial days, you can just go to the preventive treatment that we highly advise. But bear in mind that during those first days, there could be an increase on digestive processes as part of this drugged biofilm will be drunk by the animals. So very important to do these flushings to avoid this problem as much as we can. Without the animals, our advice is using 6-Virox, which is based on hydrogen peroxide and peracetic acid. 6-Virox has got a strong descaling power, more than BBZIX, so then we would be working at a dose of 1% in most cases for at least 4 hours. Ideally, just leave it working all night, and obviously flushing to remove all the water will be needed as well before taking in the new animals. This case is very good when we don't have the animals, because we are just going to put the product in there, let it work, and for sure it is going to remove everything from the inside of the pipes. The ideal treatment, as I said, it would be BBZIX Plus. Remember that it is hydrogen peroxide, added silver, organic peracids, and the nucleus, right, with prebiotics that will provide our animals with a digestive health improvement. Working with a dose between 50 and 100 milliliters every 1,000 liters of water, although we recommend starting on 100 milliliters, because this way we will see a higher intestinal improvement, and this will be very important, as we will explain later on as well. It is not only to avoid water being a vector for Salmonella by improving its microbiological quality, it is also to remove the biofilm and to avoid it from being a Salmonella reservoir, and besides all these effects, having the effect on improving the digestive health. So that would be as a water treatment. Remember, again, we can have two issues there. One where the water works as a vector, something that we often forget. We have a good biosecurity measures in place to avoid pathogens from getting in. No rodents or birds coming in either, but then we don't have any control over the water. Be extremely careful with these situations because Salmonella can just get through the water. And then we have the biofilm issue, right? Biofilm is extremely important for any enterobacteria, including Salmonella, because it works as a reservoir. Remember as well that mature biofilms will cause Salmonella-related problems. Also, always check if your water is rich in iron. And this is important to measure at least once, just to know the source, the kind of water that we are dealing with. If we find it once, normally our water will always have iron, right? As these conditions normally remain the same through time. And we will have to deal with it. Iron itself is not bad or toxic for our animals, but remember that it makes it easier for Salmonella to proliferate. In the case of cleaning and disinfection, we will see that if we don't perform it properly, there is a risk of reinfecting consecutive batches, right? I mean, the batch will get infected from the previous one that was in the same place, if obviously there was Salmonella in there. Also, biofilm is going to be important here. It is important the transmission from the outside. So a good measure that we have is using these food baths to disinfect, and we will talk about it later on as well. Disinfection of the vehicles is also important, and we normally pay a lot of attention to it, but probably we would say that food baths are more important than the wheel ditches or the disinfection of the wheels in the vehicles. And this is because basically the wheels can get a very high temperature when they are moving. So it is not the main point of contamination. But again, every point is important within the whole biosecurity measures. Another point we already said, don't forget about disinfecting the silos and the screw conveyors. These pipes from the silos to the feeders are a very important point to bear in mind, right? We have seen Salmonella-related problems in there because biofilms can happen there as well. So the main problem that we will have is the replication of Salmonella from one batch into the next one, and this is going to be due for cleaning and disinfection process failure. And here we can summarize again what we already saw before. What will that biofilm mean for cleaning and disinfection of surfaces? Well, it will make microorganisms from 10 to 100 times more resistant. And we also know that the generation of biofilm is a determinant factor for Salmonella survival on the environment, right? So every time we perform the cleaning and disinfection process, just bear that in mind. So how are we going to do a successful process? We will need to have it clear and follow step by step, right? Obviously, the first step will be removing that gross material, all the big particles, everything that we can see, before starting with the cleaning itself with the detergents. Later on, we will have to use a detergent. This is a very important point because in here we can already remove most part of the contamination. A good cleaning with the detergent, so we leave all the surfaces exposed for the later action of the disinfectant. If we don't have a good exposure of these surfaces later on to the action of the disinfection, we will not be successful. Let me see. Yeah. This is a good sheet every time we talk about cleaning and disinfection, as well as we can see clearly how important the cleaning is going to be, right? So you can see after loading the animals, when we just take them out of the farm, we have approximately 50 million colony forming units every square centimeter, which is outrage. After cleaning with just cold water, we would still have 20 millions, which is still a huge amount. That means that we have done a cleaning with cold water, and it can seem all right, visually okay, can seem to be clean, but we would still have a very contaminated environment and surfaces. If we do a cleaning with hot water and a detergent, we would have 100,000 colony forming units. In this case, most of it, as you can see, is already gone, up to 99%. But it will be the disinfection process, the one that will reduce finally to under 500 colony forming units per square centimeter, right? That chart below is good to see as well, because it was measuring a study that found out that 68 minutes were needed to clean a shed with just cold water. With cold water, detergent, and a previous wetting, the time was reduced nearly 50%. So it is important to carry out all the steps. It might seem that by adding a previous wetting, another step, it will take longer, but the reality is that it will help us reduce the action time of the detergent, right? So those previous wettings are very important, and they are very useful. So let's talk about the cleaning process itself, which will need to be written in a protocol. So failing in the cleaning process means the main failure of the whole cleaning and disinfection process, right? So see how important it is to do it properly. The goal here is to remove more than 95% of the organic material, right? It is also important to bear in mind a good design of the place, right? Where we can remove everything with a good drainage system, so we are not getting puddles anywhere. We might be doing a great job by removing organic material from some places, but it might remain later on inside of those puddles. Remember that the detergent doesn't have a great capacity to kill the microorganisms, but it will be moving them from one place into another one. So we have to make sure that in the end they are easy to go away from the place, and for that we need to have a good design in our premises. Also, soaking before the actual cleaning is very important, right? This wetting that I just mentioned before. We say there from 1 to 2 hours before, but that will basically depend on the weather from each country, the environmental conditions. We just need to avoid that wetting from drying, okay? Otherwise, it will not be very useful. With this previous wetting, we will achieve to soften the hard crusts of organic material, and therefore it will be an easier job for the detergent to remove them. Always to do it from the inside to the outside, ideally at a minimum pressure of 120 bars, and the temperature of the water should be at least 40 degrees, right? Pay special attention to both drinkers and feeders. There will be bigger amounts of grease, plus a failure here will suppose a major risk for the new animals coming in. So once we do the cleaning with detergent, don't let it dry either, but we need to let it work normally for around 20 minutes, all right? Then rinse it with just water, And this is very important to avoid detergent getting mixed with disinfectant on the next step, because this will mean losing efficiency on the whole process because they can interact. Ideally, previous to the disinfection, just after rinsing, we would need to let it dry, although we have seen that this doesn't always happen. Sometimes, just to save time, if you are not waiting until it has dried up, then you will need to increase the dose of disinfectant, just to avoid losing efficiency due to a dilution of the disinfectant applied over a wet surface, right? Normally, we say that we have to double the dose of disinfectant. So you have to bear in mind whether you prefer to spend more money on disinfectant or you just wait until the whole thing is dried. And then it is always good to also evaluate after a process the presence of microorganisms. So what other considerations do we have to bear in mind? Right, so a few things here. The kind of waters we are working with, its hardness. This was part of one of the other webinars we did. We explained that in more details, but just so you know, if we have hard waters, we have to know that we will be needing a bigger concentration of detergent in order to get a good quality foam that will stick better to the surface to perform its activity, right? Just that, no other problem there with the hardness. The pressure, as we already said, at least over 120 bars. If it's over 140, even better. That will make our job easier there, right? Always use alkaline detergents like ours, BBZIX, because they are the ones that will help you to detach the organic material. Acid detergents will only be useful to remove inorganic material, right? Imagine we have a surface with plenty of limescale due to the cleaning water itself. It is, if we are using a hard water, then if you want to make it look nice again, you can use an acid detergent, but never change the alkaline detergent. So after using the acid, carry on the cleaning process by using the alkaline detergent, because that is the one that is going to remove the organic material. And our purpose is to remove the biofilm and any kind of microorganisms which can be there, including obviously Salmonella. And basically, once we have finished with the cleaning, we will jump into the disinfection itself, right? There are so many different kind of disinfectants, but we are not going to get deeper into this because we will have another webinar where we will see that with more details. So what can we say as our advice? So always we are performing a first disinfection, but nowadays a second disinfection is getting more and more important, right? For example, in the case of broilers, we have cleaned and disinfected the whole place, but later on we will introduce the litter, whatever this one is made of, and that will mean, apart from the litter getting in, several staff walking in and around. We are more careful every day, but that means a risk of introducing Salmonella or any other pathogenic microorganisms. So it would be very advisable in this case to carry out a second disinfection. Ideally, a disinfection that provides with no humidity, as it could be thermonebulization with which provides a small amount of humidity, or a smoke disinfectant. Also, you have to be careful with underdosing, right? Most of the problems that we have noticed at this step are related for using lower doses, right? Sometimes just because we want to save products, sometimes, as we said, we don't want to wait until the whole thing has dried up. Sometimes the staff just prepare the dilution wrong, etc. Just be careful with the dose, because it's probably the main cause for failing in here. Pay attention as well to any cracks on surfaces or places where it might be more difficult to get, because biofilm will love to get in there, and obviously it's going to be more difficult to remove it. Careful with disinfectants which are not effective against biofilm. Remember, we saw how the microorganisms can become from 10 to 100 times more resistant within the biofilms. So very important to use disinfectants which are effective against it, because on the market we have quite a lot which are not, right? And obviously controlling the process is essential, right? It can be done with these colorimetric sprays, fast and not very expensive, but also we can do surface sampling, etc. For the second disinfection, as we just mentioned, we always advise thermonebulization or the use of a dry smoke disinfection, because providing more humidity in this second disinfection is not ideal, right? We have different ways of applying the first disinfection, as it can be a spray, nebulization, thermonebulization, or dry smoke, like our new product, the BIOFILM Fumigeno, or using BIOFILM to disinfect the screw conveyor system from the silos to the feeders. What else? So with the boot wash, most of the times when we have assessed the presence of the active substance from the disinfectant product inside of a boot wash, we have seen that there is not enough or there is literally nothing, right? So in these cases, which are very common, we can say that instead of being an effective preventive measure, the foot wash can become the problem, because there will be plenty of organic material inside there, and with no disinfectant products, the germs will be able to replicate. So always be careful with them and pay special attention to the amount of organic material and the amount of active substance there, especially in the cases where they have a lot of transit, because we can have this foot wash with plenty of organic material, water, and that being a place where all the bacteria, including Salmonella, are growing nicely. We have our staff just passing through it, so it's a way of spreading the bacteria. We particularly like for the boot wash, and if you have access to our product BIOFILM, using it, because of the pinky color that it has got. This pink color is going to be very helpful, as this color will be disappearing as long as the active substance gets degraded, right? So it is very useful to assess the presence of disinfectant. Sorry, otherwise we will have to measure it with reactive strips or whatever other measurement that we can perform and be aware of it, right? In the wheel wash, as we said before, they are not that important as the boot wash for Salmonella. What other thing is very important nowadays? So choosing obviously disinfectants which are non-toxic, carcinogenic, or allergenic, right? We have to look after our people and our staff. What other important tips we must remember, right? So the stock solution. When we prepare these stock solutions of disinfectants, just prepare it for 1 day, or try to prepare not a large amount. So don't use it any longer. And this is for any kind of disinfectant, absolutely any of them, right? They will start reacting with the minerals and any possible organic materials inside the water. So if we keep that stock solution for more than 1 day, we might be losing efficiency on the whole process. Also, the residual effects, we hear a lot of people talking about it at the moment, especially when talking about the coronavirus, right? If we disinfect an office and there is some active substance remaining on the surfaces, okay, fair enough, it can decrease the load and we might have some residual effect. But think about our farming environments. The organic material load is so high. We have litter, we have fecal material, etc. that is our reality. The residual effect doesn't exist at all. So just remember this, because some people will be telling you about residual effect of their disinfectants. Just don't get that feeling of being safe with it, because that will be a fake safety. And another important thing for boot wash, disinfection arches, and anything where we are using disinfectants on an open environment, is using biodegradable disinfectants, as it can be BBZIX Virox, right? That will help us a lot with the waste management, right? And we will not be causing any harm to the environment. The UNE standards for disinfectants to be considered efficient say that they need to decrease 5 logarithmic units for bacteria and 4 logarithmic units for fungi. That basically means, as you can see there, reducing 5 zeros for bacteria, going from 60 million to 600 colony forming units. But that is just so you know what is considered to be efficient. So what is the satisfactory level for Salmonella on surfaces, etc.? Literally 0. The presence of Salmonella is not accepted in most cases. There is a minimum tolerance, but consider it in special cases, but consider it 0. We have to always look for the 0. In some other bacteria, as it can be aerobic mesophilic bacteria, etc., we could have a little bit more of flexibility. We could be a bit more tolerant. But in the case of enterobacteria, and especially Salmonella, the tolerance is nil. Normally, every country has got its own official control plans for Salmonella, so you would just need to follow that legislation, right? And for the last, the other aspect where I said that we can be a good help for you. Remember, we said that we cannot help you with Salmonella in the whole process, because there are multiple factors involved, as pest control, staff control, feed, etc. So apart from the ones explained before, water, biofilms, cleaning and disinfection, what can we do if we already have Salmonella with us, right? We need to improve the digestive health. We know that Salmonella is a really bad competitor. So being like that, if we have Salmonella inside the intestine, but we have a good intestinal health, our saprophytic bacteria will be able to unseat Salmonella, right? And therefore, its effect will disappear, even though having the bacteria in there, right? That basically means that by competing, we can remove the effects of the bacteria, but not making the bacteria disappear. We did a trial with CESAC in 2008, which is the Poultry Health Center of Aragon and Catalonia, with Aqua6 Plus, which is based on hydrogen peroxide, silver, plus the nucleus and the prebiotics, with laying hens. And this was quite a good study. So basically, we infected the hens with 2 consecutive doses of Salmonella enteritis in 2 different days, right? As you can see, we use a very high dose of the bacteria, much higher than what you would expect to find on a natural way, right? So this way, we made sure that 100% of those hens were positive for Salmonella. And then we studied the colonization of the digestive tract and some organs by the bacteria. We separated them in the hens into different groups. On the group 1, the hens were drinking water with Aqua6 Plus, as you can see there, at a dose of 140 milliliters every 1,000 liters of water. That is not a preventive treatment because the bacteria is already there, and we don't want to avoid the entrance. We want the hens to be positive for Salmonella, so we treat them with later with that dose. And the other group, the group 2, where the hens are drinking water which is not treated with Aqua6 Plus. What is it then that we found on the day 17 post inoculation after inoculating them with Salmonella? We saw a reduction of 30% when isolating Salmonella enteritidis from the group 1, the one treated with BBZIX, from the liver and spleen, right? So let's say that it helps reducing the systemic colonization of Salmonella in both organs, liver and spleen. But on the day 22 post inoculation, we found a reduction of 100% when isolating Salmonella enteritidis from the group 1, again the treated one, from the cecum in the large intestine, right? So the animals from group 1 drinking water treated with BBZIX+, they could remove the fecal contamination, and this is our main finding, right? Besides, we saw that in those animals there was also a productive improvement, seen as a nearly 17% higher egg production. But the main thing, which is important for us today, was the control of Salmonella in the large intestine. Again, we saw that it helped to remove the Salmonella from the intestine, but careful, this is not a total removal of the bacteria. But we can conclude that by using BBZIX+ and improving digestive health, we can help removing the Salmonella from the intestine, and it also helps acting as a barrier for a possible systemic colonization by avoiding the entrance through the intestine wall, right? Anything that helps improving the digestive health will help achieving the same goal against Salmonella, right? Not only with BBZIX+, but anything that is going to improve this digestive health. Another case, and this was not a trial study with a research center like the one before. So this was a real case from one of our clients in Colombia, where there is a really extensive area producing eggs with a high density of animals and real problems with Salmonella gallinarum, resulting in high mortality rates and big production falls, right? So they started a treatment with BBZIX+ at a dose of 200 milliliters every 1,000 liters of water. See that this is a high dose, but you don't have to worry about the dose because it's quite a safe product. So we still have a big margin there. And also they were disinfecting the litter on a daily basis with 6 Virox. These hens were not caged, so obviously the risk is higher because they will have access on the floor to any Salmonella excreted by any of the other hens. So basically their goal with this treatment was improving digestive health with BBZIX+ by using it in a batch which was already tested positive for Salmonella, right? So they did it in a batch which was positive, so they knew there was Salmonella there. And also they wanted to reduce the infecting load by disinfecting the litter with 6 Virox. So we could expect obviously there an improvement. And what happened there? What is it that they found? So before the treatment, they had very high mortalities, up to 30% on the batches tested positive for Salmonella, and big production falls, right? But when they started doing this treatment on positive batches, then the results were similar to the batches tested negative in terms of both mortality and production. So the main thing to know about it is that when you improve the digestive health to control Salmonella, because Salmonella is already inside the farm, you can minimize the problem, but it will be extremely hard to get rid of Salmonella in the whole thing, right? In this particular case, they told us as well that as soon as there was a mistake when applying this protocol, a mistake of dosing, or they just literally forgot to replace the BBZIX jerry can when it was empty, then the mortality was rising up quickly again, and the production was falling again. So this proves how important is the digestive health to control Salmonella and how we can do it through Aqua 6 Plus, right? But remember, once the bacteria is with us, we cannot get rid of it until we finish the batch and we perform a proper emptying with a good cleaning and disinfection process. So basically, this is it for today on how we can help you to control Salmonella. Remember treating the water to avoid it from being used as a vector. Remember as well the importance of biofilm in regards to Salmonella, because it will be a reservoir both in the pipes, but also in any kind of surface. Pay attention as well to the silos and the screw conveyor systems getting into the drinkers, because we normally forget about those and they are great places for biofilm. And of course, the digestive health, how important it is to minimize the negative effect of Salmonella.